list of opportunities go on, which is the reason why AI addresses the segment of the economy that IT has never addressed. IT is a few trillion dollars that sits underneath the tools of a $100 trillion global economy. Now, for the first time, AI is going to engage that $100 trillion economy and make it more productive, make it grow faster, make it larger. We have a severe shortage of labor. Having AI that augments labor is going to help us grow. Now, what's interesting about this from a technology industry perspective also is that in addition to the fact that AI is new technology that addresses new segments of the economy, AI in itself is also a new industry. This token, as I was explaining earlier, these numbers, after you tokenize all these different modalities of information, there's a factory that needs to produce these numbers. Unlike the computer industry and the chip industry of the past. Notice, if you look at the chip industry of the past, the chip industry represents about 5 to 10%, maybe less, 5% or so, of a multi-trillion dollar, few trillion dollar IT industry. And the reason for that is because it doesn't take that much computation to use Excel. It doesn't take that much computation to use browsers. It doesn't take that much computation to use Word. We do the computation. But in this new world, there needs to be a computer that understands context all the time. It can't pre-compute that. Because every time you use the computer for AI, every time you ask the AI to do something, the context is different. So it has to process all of that information. Environmental, for example, in the case of a self-driving car, it has to process the context of the car. Context processing. What is the instruction you're asking the AI to do? Then it's got to go and break down the problem step by step, reason about it, and come up with a plan and execute it. Every single one at that step requires an enormous number of tokens to be generated, which is the reason why we need a new type of system, and I call it an AI factory. It's an AI factory for sure. It's unlike a data center of the past. It's an AI factory because this factory produces one thing. Unlike the data centers of the past that does everything, stores files for all of us, runs all kinds of different applications. You could use that data center like you can use your computer for all kinds of applications. You could use it to play a game one day. You could use it to browse the web. You could use it, to do your accounting. And so that is a computer of the past, a universal general purpose computer. The computer I'm talking about here is a factory. It runs basically one thing. It runs AI, and its purpose is designed to produce tokens that are as valuable as possible, meaning they have to be smart. And you want to produce these tokens at incredible rates because when you ask an AI for something, you would like it to respond. And notice, during peak hours, these AIs are now responding slower and slower because it's got a lot of work to do for a lot of people. And so you want it to produce valuable tokens at incredible rates, and you want it to produce it cost effectively. Every single word that I used are consistent with an AI factory, with a car factory, or any factory. It is absolutely a factory. And these factories never existed before. And inside these factories are mountains and mountains of chips. Which brings to today. What happened in the last couple of years? And in fact, what happened this last year? Something fairly profound happened this year, actually. If you look, in the beginning of the year, everybody has some attitude about AI. That attitude is generally, this is going to be big, it's going to be the future, and somehow, a few months ago, it kicked into turbocharge. And the reason for that is several things. The first is that we, in the last couple of years, have figured out how to make AI much, much smarter. Rather than just pre-training basically says, let's take all of the information that humans have ever created, let's give it to the AI to learn from. It's essentially memorization and generalization. It's not unlike going to school back when we were kids. The first stage of learning. Pre-training was never meant, just as preschool was never meant to be the end of education. Pre-training, preschool, was simply teaching you the basic skills of intelligence so that you can understand how to learn everything else. Without vocabulary, without understanding of language and how to communicate, how to think, it's impossible to learn everything else. The next is post-training. Post-training, after pre-training, is teaching you skills. Skills to solve problems, break down problems, reason about it, how to solve math problems, how to code, how to think about these problems step by step, use first principle reasoning. And then after that is where computation really kicks in. As you know, for many of us, we went to school, and that's, in my case, decades ago. But ever since, I've learned more, thought about more, and the reason for that is because we're constantly grounding ourselves in new knowledge, we're constantly doing research, and we're constantly thinking. Thinking is really what intelligence is all about. And so now we have 3 fundamental technology skills. We have these 3 technologies, pre-training, which still requires enormous amount of computation. We now have post-training, which uses even more computation. And now thinking puts incredible amounts of computation load on the infrastructure because it's thinking on our behalf for every single human. So the amount of computation necessary for AI to think, inference, is really quite extraordinary. Now, I used to hear people say that inference is easy. Nvidia should do training. Nvidia's going to do, they're really good at this, so they're going to do training. That inference was easy. How could thinking be easy? Regurgitating memorized content is easy. Regurgitating the multiplication table is easy. Thinking is hard, which is the reason why these 3 scales, these 3 new scaling laws, which is all of it in full steam, has put so much pressure on the amount of computation. Now, another thing has happened. From these 3 scaling laws, we get smarter models. And these smarter models need more compute. But when you get smarter models, you get more intelligence, people use it. If anything happens, I want to be the first one out. Just kidding. I'm sure it's fine. Probably just lunch. My stomach. Was that me? And so where was I? The smarter your models are, the more people use it. It's now more grounded. It's able to reason. It's able to solve problems it never learned how to solve before because it could do research. Go learn about it, come back, break it down, reason about how to answer your question, how to solve your problem, and go off and solve it. The amount of thinking is making the models more intelligent. The more intelligent it is, the more people use it. The more intelligent it is, the more computation is necessary. But here's what happened. This last year, the AI industry turned a corner. Meaning that the AI models are now smart enough, they're worthy to pay for it. Nvidia pays for every license of Cursor, and we gladly do it. We gladly do it because Cursor is helping a several $100,000 employee software engineer or AI researcher be many, many times more productive. So of course we'd be more than happy to do that. These AI models have become good enough that they are worthy to be paid for. Cursor, 11 Labs, Synthesia, Abridge, Open Evidence, the list goes on. Of course, OpenAI, of course, Claude. These models are now so good that people are paying for it. And because people are paying for it and using more of it, and every time they use more of it, you need more compute, we now have 2 exponentials. These 2 exponentials, one is the exponential compute requirement of the 3 scaling law. And the second exponential, the smarter it is, the more people use it, the more computing it needs. 2 exponentials now putting pressure on the world's computational resource. At exactly the time